So anyone would like to have recollect what we did in the last class? So we studied about the classification, 2D classification. We saw what is 2D binary classification. We saw multi-class classifications.
AC போட்டுடுமா அம்மாக்கு வேர்க்குது.
And we saw about multi-class binary classifications. In that we saw 2 types. Then we saw about clustering. And we saw about the curse of dimensionality. So we got a clear idea about the principles involved in the classification. Today in this class, we will learn about training and testing. So what we are going to learn about training and testing is that we want to train our system. We want to learn how far it can learn from the data, how well it can learn, and how well we expect it to perform on the new data that it has never seen before. So learning from a system means extracting meaning from the data. So sometimes we want to understand the data set which we already have. Sometimes we want to understand the data which is yet to come. So there are 2 types, one which we have and the one which is going to come in the future. So we want to understand both these data sets. So what this essentially training is that it is a process of taking the system and then initializing it with random values, reconfiguring it again, so that we can understand the data which we want to understand. We will also see about how to validate the system. So validate the system is validating the system is nothing but evaluating how well the system is learning. So how well it will perform on the new data, and how we can measure accurately that what it is able to extract from the data. So we will also see about cross validation. Cross validation is nothing but a validation tool. This is particularly helpful when the data set is small. So if all the predictions on the validation data set is good, then we can start using it in the real life. If the data set is, so if the predictions are not good, we have to go back and train again. So we will learn all these concepts in this class. So let's start with training. So what is supervised training? Anyone would like to tell? We have spoken about this before also. What is supervised learning?
Ma'am?
Yeah.
Ma'am, where we tell the machine and we do the labeling, then it is supervised learning. If the machine itself does the classification and all, it comes under unsupervised learning.
So it is all with the labeling thing. So every sample has an associated label. So if every sample has an associated label, then we call it as, and it is used in the learning algorithm, we call this as supervised learning. Because we are describing the category which has been manually determined to be the correct one. So sample attached with the associated label in the learning algorithm is called as supervised learning. Label only sample is there, and as you said, if the classifier itself is assigning the classes, it is called as not assigning the classes, splitting them into clusters. So if it is doing it, then it is called as unsupervised learning. So what is a training set? So a training set is nothing but collection of samples. So it is nothing but the collection of samples which we are going to learn along with their labels. So it is samples plus labels which the classifier is going to learn or the model is going to learn. It is called as the training set. So what is prediction? Prediction is that each time when we present a sample to the training set, the classifier is going to assign one or the other category to it. So each time you have a classifier model. So each time you will present a sample. So each time one sample is presented along with its features, it is going to predict a class for it. Predict a label or a class. So this is called as prediction. If the prediction is correct, then we can move to the next sample. If the prediction is not correct, then what we have to do, we have to learn our classifier. So how we can model this one? So let us assume that we have a training set. So this training set has features and label and their associated label. So this is feature number 1, feature 2, feature 3, feature 4. Sorry, number of samples. Sample 1, sample 2, sample 3, sample 4, along with their labels. You have n samples. So each time we take a feature along with its label, give only the feature to the classifier. Let the classifier make its prediction. If the prediction is same as the label, input label, then what we will do is that we will go fetch the next sample and then give it to the classifier. If the prediction is not same, what we will do is that we will update the classifier. Classifier outcome, correct label, and the status of the classifier will be given to the updater and it will update the classifier. So it will change the internal variables of it so that it can do the good job in predicting. So if the prediction is same as that of the label, what we will do, we are done with this sample. So we will go fetch the next sample. If it is not correct, what we will do, we will update the classifier. So this is how. So each time we need to run through the entire data set. So this is your training set. So running completely through this entire training data set is called as epoch. So one epoch is, so it is running through the entire training set. We say that we have trained for one epoch. Usually a classifier will be trained, or a classifier or a model will be trained for many epochs. So as long as it is learning, we will be training on it and improving the performance. So when to stop the training? So this is happening. So every time we fetch a sample, feed it to the classifier, make the prediction, and then we check compare the predictions, and then we go for the next sample or we will update the classifier. So when to stop this process is, so once when we run out of time, we can stop the training. or else if the system has reached enough performance. Then we can stop the training. So in these two instances, we will stop our training. So what is the training data set? Training data or training data set? So what is it? It is the data which is used to train the system, or it is the data which we start with. It is the data to start with, but it is not the data that we will see in the real world. The real world data is something which the system will see only after releasing. So training data means it is the data which we start with, and it is the data which is used to train the system. So until we achieve what to say, a certain threshold of accuracy and performance, we will be training our system. So how can we estimate that the quality of our system predictions before it is released? So imagine that we have got perfect training accuracy. It doesn't mean that if you have got perfect accuracy, it is enough. If it is doing well on the training data, it is enough. It has to it has to perform well on the test set. Then only we can say it is doing well. So let us take an example. Let us take an example of a supervised classifier. So we will look into the pictures of dogs and then assign a label to the dogs. Imagine we have 1,000 pictures of dogs, and every sample has a label. Label of the breed. So the label is nothing but the name of the breed. So what we want to do is that we want to train a classifier to predict the name of the dog's breed, and we want to deploy it in a web-based system. So tomorrow somebody picks their dog photograph and then feed it in the website. It has to give the name of their dog's breed. So this is the system which we want to deploy. So imagine it is performing well in the training data set. We have got good accuracy. But what happens that if you deploy our system in the website, whether it will perform well or not, we do not know. So it doesn't mean that if the training is 99% accurate, the web deployment also will be accurate. There are 1,001 reasons it is. Even though we will show our what to say, 1,000 pictures over and over again, there can, and in a jumbled order, we will show it to the system, and then we will train. We will adjust the internal parameters if it is something is wrong and other things. It may or may not work correctly. Why? Because we never know what the classifier has learned. So let's take one example. Suppose there is a dog. I'm not good in drawing a dog, but just for our understanding. So if the dog's tail has a bob, so this is a dog called poodle. So the poodle dog has a bob in the tail. So whichever dog has a bob in the tail, it might recognize that it is poodle. Or else let's take a very simple example. So we have pictures of the dogs of Yorkshire lying on the couch. So if the dog is lying on the couch, all the Yorkshire dogs has been lying on the couch. So what the system assumes is that the system will assume that if there is a dog on the couch, it is called as Yorkshire. So instead of learning about the dog, it learns about the couch or the sofa. So if it sees a sofa, it will understand that, okay, the dog which is present on the sofa is called as Yorkshire. Tomorrow you have a husky or a Pomeranian sitting on the sofa, and then you show the picture to it. It will label as Yorkshire. So what it is doing here is that it is having a strange behavior of learning these weird rules. So if it has a white bob at the end of the tail, then it is called as poodle. So tomorrow, if some dog has a white bob at the end, it will name it as poodle. So it is it is a weird behavior of the training data because it is learning some specific rules. So it is not generalizing. So what we need to do is that we have to feed it with enough data. Is there any formula to understand if the training is good or if the algorithm is good? If you ask, there is no formula or no algorithm or no way to know that how good our system has learned. Without trying it and seeing out, there is no good way for doing this one. So what we have to do is that we have to train it with even more good number of samples. So we have to train it with samples with Yorkshire without sofa or some other breed sitting in the sofa. We have to train such things, and also we have to train with the dogs with different bobs in the end, so that it will not understand the weird rules in doing this one. So the best way to know that how our system is performing or how the training has learned, it is to by testing. So we the best way anyone can has found to work out is how well the system will do on the unseen data is to give new unseen data and see how well it works. That is the only way. There is no shortcut for this experimental verification. Is it clear? So we are talking about training. So in the training, we wanted to know how well our system is performing in the training. So we have taken the examples of the dog, and the classifier will give the name of the dog's breed as its label. So we have seen some weird examples where the system is learning some strange rules and then applying it on new data. So what we need to do is that we have to test and see how it works. There is no other way apart from testing it on unseen data. There is no other way to know how well that our classifier has learned these things. Is it clear? Is it clear? So next we will talk about our test data. So test data is nothing but the collection of data points, new collection of data points which the system has not seen. So it can be called as test data or test set. So the typical process is that we will train our system with the training data until it is doing well, we will evaluate. Suppose imagine that the test data is very good. So we get accurate results in the test data, but it is not performing well on the training testing data. Sorry, if it is performing well on the training data, in the training data we get good accuracy. But in the test data, it is not performing well. So what we have to do, though it performs well on the training data, it is not performing well in the testing data. So we have to go and retrain. So either we can retrain from the scratch, or what we can do is that we can evaluate, we can just add some new data and then refine our training on that one. So either way, what we can what we are doing is that we are trying to avoid the learning the weird rules so that it can perform well on the new unseen data. So what we can do, we can give some photographs of the dogs which is sitting on the couches. Apart from Yorkshire, we can give many photographs of the dogs which is sitting on the couch. So many breeds of the dogs sitting on the couch, we can give that data so that it will understand that it is not just one type of dogs are there. So there are multiple types of dogs, and also we can give uh, what to say. We might give other than poodle, so we can give the dogs which has a bob on their tail, so that it could find ways to classify these dogs and avoid these weird behaviors on the original training data set. So sometimes it might be tempting that we have the test data set. Why can't we learn from the test data set? But why we should not learn from the test data set? Anyone would like to answer this? So we have a training data set. We are learning from the training data set. We have a testing and we are checking how it is working on the test data set. Why we should not learn from our testing data set? Anyone would like to comment on it?
Yes, ma'am.
Yeah.
May I? Yeah,
Yeah, please.
maybe the test data is the only way how we test our module or set training.
Fantastic.
How well our training has been happened. So the test
Fantastic.
data should be separately.
Yeah, otherwise it will lose its special and valuable quality as a way of measuring the performance of the system. So that is the only way to measure our performance of the system. If we learn from the test data, what will happen is that it will become a part of the training data. Then it is cheating. Then again, because the classifier has already seen the data, then there is nothing special about it. We will not know how it will realize in the real world data set. So to see how well it will perform on the real world data set, we need to keep our testing data hidden. So the problem of learning, sometimes what will happen is that sometimes we will learn from the training data set. So the problem of learning from the test data is called as data leakage. You would have heard this term before, but data leakage means we are learning from the test data or data contamination. Or otherwise, we can call it as working with contaminated data. So what will happen is that when we are learning from the test data, it is not that there is only data leakage. What it will do is that it will learn the statistics of the test data, such as it will learn the range of the values, it will learn the mean, standard deviation. So we have to meticulously keep it separate. Otherwise, it can learn the statistics and it can contaminate our data set. So let's understand the difference between the training and testing. So in the training, what we will do, we will take each sample from the training data set. So we'll have a training data set. So we'll take each sample. Each sample will have a feature and a label. We'll give this feature to a classifier. It will predict those features. And what we will do, we will compare the prediction with the input label. We will get the results. If the results are good enough, we will go fetch the next feature. If the results are not good enough, what we will do, we will update the classifier so that we will be learning. So this is what is happening in the training process. In a test process, we will have a test set. So we will take the feature and the sample label from it. For each sample, we will take the feature and the label. We will feed the feature to the classifier. The classifier will predict the outcome. Then we will compare the results of the prediction with the test label, and we will get the results. So if you look at the training process, and the testing process, the difference is the learning mechanism is disconnected in the test set. Here we have a learning loop where we update the classifier. If you look at here, everything is same. Everything is same to the right side, but in the left side, the learning mechanism is disconnected. So once the learning is over, what we do is that we take the system and we use it only for evaluating the system. We don't keep on learning it. So once the learning is over, we understood learning is over and we only use it for our evaluation. So we need to keep our test set hidden from the learning system, or we have to keep it hidden from the training data. So if you have an input data, So we divide the input data. We take it as a training, one chunk as a training set, and another chunk as a test set. The splitting of our input examples into training set and testing set, the splitting is often 75%, 25%, or 70-30%. So 75% can be training and 25% can be used for testing, or sometimes we use 70% for training and 30% of the data for testing. So often we choose these samples randomly from each set. So there are machine learning libraries which offer routines to perform these splits. So the final step before deploying, what we need to do with the learner is to evaluate the quality of the learner. So that is the last thing which we will do before the deployment. So if the system is doing well enough, then what we will do is that we will go on fetch the next sample. If the system is not doing good enough, what we will do is that we will go back for our training. If the system is doing good enough, sometimes if all the samples are also over, what we will do, we will deploy it. If not, we will go for training. Even if our test data is a representative of the overall input, we might still wish to have more cases to work on or evaluating the systems. So is it clear? So far what we have seen is that we started off with training. We took an example of supervised learning. We saw the processes involved in the training a classifier. And then we learned what is the term called epoch. Epoch is seeing the training samples at least once. One time seeing all the training samples is called as epoch. When writing a machine learning algorithm, we will train our system with multiple epochs. So multiple times we will see all the training examples. So we learned when to stop the training, and we learned the definition of the training data set. We saw an example of supervised classifier. And what are the problems involved in the test data? That is data leakage and data contamination. And we saw the difference between the training process and the testing process. And we saw the split up between the training data and the test data. And we also got the rules for when the prediction is good, what we need to do. When the prediction is not good, what we need to do. So is it clear? Any doubts so far? Do you have any doubts? Any questions? So if you have no questions, then we will go to the next topic. So we often derive another data set in addition to the training set and the testing set, which is called as validation data set. So we have an input data. So this input data can be split into three parts. The first part is training set. Second part is validation set. The third part is test set. So the split up can be 60%, 20%, 20%. Sometimes we can do 70%, 15%, 15%, but usually this is preferred. 60, 20, 20 is preferred. This way of splitting of the data is useful when we use some automated searching techniques to try out how many values for hyperparameters has to be chosen, or which is the best hyperparameters to be used. So hyperparameters are the variables that we set before we run our system to control how it operates. So is it clear? Hyperparameters are the values which we set. Parameters are the value which the system changes itself. So for each variation, we train our training data set and evaluate the system performance on the validation set. So we learn using the training data set, and then we will evaluate on the validation set. Test set is kept separately. We saw the use. So far we learned what is training set, and we learned what is a test data set. So validation set, why it is used is that it is used to get the hyperparameters. So how it is used, we will see here. So first, what we will have is that first we will make a list of hyperparameters which we need to try. So hyperparameters are the list of parameters which control the system, and it is set by us. So the parameters of the training model is given by the internal parameters. So I mean to say these hyperparameters are set by us and parameters are changed by the model itself. So we need to know what are the good list of parameters hyperparameters which we can use. So we do not know how to select it. So this validation set will help us select these hyperparameters. So we got to know the purpose of training set. We got to know the purpose of test set. Now we are understanding why we need a validation set and how it is used. So validation set is used to choose the best hyperparameter for our model. So hyperparameters control our model. So what we will do is that we will make a list of hyperparameters which we want to try. We will take once we make the list, what we will do is that we will get the set of hyperparameters. And then what we will do is that we will build our classifier from those hyperparameters. And then what we will do is that we will train our classifier with the training data set. And then what we will do is that we will evaluate this classifier with the validation set. And then we will save the evaluation results. So if the list is done, what we will do is that we will go back and fetch the next set of parameters. If the list is not done, if the list is done, then what we will do is that we will get the classifier with the best hyperparameter. And then we will evaluate the test result. Finally, we will deploy our model. So is it clear? First, we will create the list of hyperparameters which we want to try. Then we will take the first set of hyperparameters, build our classifier with the hyperparameter, train our classifier. For that, we will be using the training data here. And then we will evaluate with the validation set. So we will use the validation data here. So once it is trained, we are evaluating it on the validation data, and then we are saving the results. Then for the next set of hyperparameters, we will again train our new classifier, and again we will evaluate the validation set. So it will go on till we finish all the set of hyperparameter list which we have. It will still go on, and then we will check how it is working on the training data set, and how it is getting evaluated on the validation set. Once the list of hyperparameters are done, we will choose the classifier with the best hyperparameters for which the evaluation results are good. So we will choose that classifier with that best hyperparameter list, and then we will evaluate the test set with that hyperparameter. And finally, we will deploy our model. After evaluating on the test data set, we will go on deploy our model. So here we use the test data. So 60% of our data will be used in the classifier, 20% will be used here to evaluate the validation set, and 20% is used in the test set. So test set is to see how well our classifier is performing. So evaluation data set is used to choose our hyperparameters, and training data set is used to learn the classifier model. So is it clear? Is it clear? So you need to know why we use training data set, why we use validation set, and why we use test set. So sometimes you might ask, we already have a test set for test set to see how well it will work on the real life data set. We have a test set to evaluate. Why we need to have another validation set? So this validation set is also like a test set. Our model is not learning from the validation set. Then why we need to have a separate validation set? Anyone would like to answer this? So why we need a validation set? Why can't we use the validation set in the classifier training itself? Why we need to take a separate chunk of the input and use it as a validation data? Why we need to use waste 20%? Any thoughts on that? Okay. So why we need a separate validation set is that of course, our classifier is not learning from the validation set. It is learning only from the training data set. It is just like the classifier is not looking at the data of the validation set. But though the classifier is not using not learning from the validation set, the whole evaluation model and the classifier is using the data in selecting the hyperparameters. So we choose the best hyperparameter based on the evaluation on the validation set. So we have already chosen the best hyperparameters from this one. So we will know that for this hyperparameter, this validation set will work out well. So we already learned and we have tuned the classifier based on this hyperparameter. So there is already a data contamination. So if you learn from this one, or else what will happen is that we are creating a data contamination here. We have to be vigilant about the data contamination. It is easy to overlook or miss these details, but we need to keep it set it aside because we are choosing the hyperparameter from it, and the classifier is learned using these hyperparameters. So that is the reason we need to keep it separately. But we need to miss out a big chunk of data in validation. So validation set is necessary, but it takes out a lot of data from the training data. So there are some clever techniques which have been developed around. So it will avoid the need to separate validation data sets. We will learn some of the techniques today on how to not lose data at the same time still have the validation data. So in the above discussion, we learned that the training set was still large enough to do a good job. But what will happen if you have very less amount of labeled data? So getting more data is also impossible. So what we will do when we have limited number of samples? So that time we will use a technique called cross validation. So because in the previous discussion, we learned that only 60% of the data is used in training set. So what we will do is that we will, without permanently creating what to say, a set for a validation, we will temporarily assign validation sets. However, a test set is permanent. We have separated the test set, but validation, we wanted to keep it separately so that, we want to create it temporarily so that we don't lose out the data and we don't create a permanent partition for the validation data. This technique is called as cross validation or rotation validation. So the best benefit of this cross validation or rotation validation is that we will use all of our data in training. So to start, what we will do is that we will take the test data and keep it aside, and then we will do this process. So what we will do is that first we will start. When we start, we will build a new instance of a classifier. And then we will split the training set into temporary training set and temporary validation set. Then what we will do is that we will train the classifier with temporary training set. And then we will evaluate this with temporary validation set. And then we will save the score. We'll repeat the loop until we finish. So once it is done, we will report the average of all scores. So what we will do, initially we will start a new instance of classifier. Every time we are starting a new classifier. So what we will do is that first we will split the training data set into temporary training data set and temporary validation set. And then we will train using the temporary set and evaluate using the temporary validation set. And we will, evaluation score will be assigned for this validation set. Then we will create a new splitting again, new classifier and a new splitting of training data and validation data. And then we will repeat this process. And finally, we will collect the average of all the scores and then report it as the score of the classifier. So is it clear? Is it clear? So this split is temporary only. So every time it will go through the loop, it will create a new split of training and validation. How each time through the loop we will split, we will learn now. So for every fresh classifier, there is a score, and final score is nothing but the average of each of these scores. There are different algorithms for constructing this temporary training and validations that we will look into. One thing, if you look at the system, there is no data leakage. So everything happens within this loop. Within this loop only, we are temporarily creating the training set and validation set, and then that partition exists only for the one iteration of it. Next iteration, there is a new classifier, new set of training data, new set of validation data. So there is no confusion in it, and there is no data leakage. So in the second time when it comes, we take a different training set and a different validation set. So now we will learn how to partition this training data set and the testing data set, sorry, validation set. So one algorithm for building the temporary data set is called as k-fold cross-validation. So k-fold cross-validation is used to build the temporary data set. So it is called as, here k is nothing but an integer. For example, you can say two-fold cross-validation, or five-fold cross-validation. The value of k is nothing but the number of times we want to go through this loop. So what we do is that you usually, the number of split ups the data has and the number of times it has to go through, we will keep it as the same number. So suppose if you have a training data set in k-fold validation, so imagine this is a training data set. So what we will do is that in a five-fold cross validation, we will take the training data set, divide it into equal 5 chunks or equal 5-fold. This is fold number 1, fold number 2, fold number 3, fold number 4, fold number 5. So we make into 5 partitions. And then what we will do each time is that each time, so for the first loop index, so what we will do here is that for the first loop index, F1 will be used as a validation set and F2 to F5 will be used as a training set. In the second iteration, what we will do is that we will use F2 as a validation set and rest F1, F3 to F5, we will use it as a training set. Then what we will do, we'll use F3 as a validation set, F1, F2, F4, F5 will be used as a training set. And then what we will do, F4 will be used as a validation set, F1 to F3 and F5 will be used as a training set. In the last iteration, F5 will be used as a validation set, F1 to F4 will be used as a training set. So this way, we are temporarily partitioning the training data set and the validation set. Every time one fold is used as a validation and the rest of the folds are used for the training. So what is the advantage of this method is that so collectively, if you look at, we have built 5 classifiers. So average of these 5 classifiers will be reported as the final evaluation score. So in the average, all the training data set has been seen. So nothing has been left out. Everything has been used in the training and everything has been used in the validation also. So it is benefit. So we are looking at all the training data. We are not missing out any training data, and also it is only a temporary partition. So number of times we are looking at is equal to the number of folds. Sometimes what will happen is that if the training involves some random numbers, we can repeat it as many number of times possible. It is not just we have to stop it with 5 iterations. We can go for 10, 20, 30 iterations also. The beauty of this scheme is that we will get to use all our training data without splitting into permanent test and validation, training and validation set. We will be looking into all the parts of the training data. So instead, we want to make so instead of creating a permanent partition, we are creating a temporary training and the validation splits, and we are going through each loops. Is it clear? So this makes cross validation a great option when we don't have much data. So when we will use cross validation is that when we don't have much data, we will use cross validation so that we don't lose out our data on the validation, but it will really give a good estimate for the quality of the system. We don't have to repeat the training and the validation times many times. The downside is that 5 times we have to run through the system. Instead of building one classifier, we have to build 5 instances of the classifier. But the advantage is that we can trade off our running time for the ability to train our data with ability to train with all the data. So is it clear? So next we will look into of using our results of testing. So anyone would like to tell where we will use our testing data, or what is the use of our testing data? So what is the purpose of our testing data? Anyone would like to tell?
Ma'am, we can use these results of testing data for deploying our model, or
Okay.
we will draw a conclusion whether we are our model is good enough to deploy in large scale or into the real
Okay.
world scenario.
Okay. So I can say it as evaluation, right?
Yes, ma'am.
Evaluation of the real world scenarios to check if it is suitable for the real world or something. So this is fantastic. So the first thing is that we would like to know how well it will work on the real world data set when we release into the wild, how well it will predict. So that is the first thing. So and the second thing is that suppose if the system is performance is good, we can deploy it and we can let people use it. If the performance is not good, then we have to think of rebuilding our data set again. Sorry, rebuilding our classifier again. So if the performance is good, we can deploy the model. If the performance is not good, then we have to build our learner again. So sometimes we can also use it to evaluate or quantify the performance of a system by publishing a paper. So a test set can be useful for publishing a paper, evaluating different kinds of algorithms in contest or in competitions. And the second application, and third application where it can be used is that it is useful during training time. So it helps us to pick the best hyperparameters, because if the performance is not good, we are going to rebuild our classifier. That time we will choose a different hyperparameter. So it will help us choose the best hyperparameter for a particular system. So we are just trying to find the best settings for the hyperparameter that can control our system. So test set can be helpful in finding out the uh, best thing. There is no hard and fast rule for it. So we proceed with our experience and intuition, both of which are generally can improve with more data set and specific systems. There is no hard and fast rules for all these things. This is the rules which has been generally followed, but we try to change it as with our experience and intuition. So these are the ways test set is helpful for us. So what we did is that so we started off with the validation data. We saw that validation data is helpful in picking up the right hyperparameters for us. Test set is used for the evaluation. Validation set also we use it like a test set. The training set, the classifier does not learn the data from the validation set, but however it chooses the hyperparameters for us, so that we should keep the validation set separate from the training data set. And we saw the process involved in setting the in using the training set, validation set, and the test set. We also saw the technique of cross validation. Cross validation is used whenever a data is less. So cross validation, there are several techniques in cross validation, but everything has the same structure. The same structure is creating a temporary partition for the test set and the training set and the validation set. Every time we build a new instance of a classifier and we create a temporary partition for the training set and the validation set, and then we evaluate it, and finally we report the average of all the scores. For every each classifier will have a score, so we will report the average of all the scores towards the end. And we saw one technique of creating the temporary partitions of training and validation set. It is called as k-fold cross validation, where k is an integer here, and we saw how to do that one. And we also saw where our test results will be testing where our testing data will be useful. Is it clear? Okay, I need to make an announcement here. Can we stop the recording here? Srinath? Okay, I need to make an announcement. So next week we will not have class. We will have week after Tuesday, we will have our class. So next week I'm not here, and I will compensate this class later on. If you have any doubts, we can discuss it now. Otherwise, we will see week after. So the next day class will be on 25th February. We will have the next class.
Thank you.
Okay, thank you all. If you have no doubts, we will see in the next class.
Thank you very much, ma'am.
Thank you, ma'am.